Okay, hi, good evening, okay, 3A6. You should be viewing this video as part of your SDL series on coordinate geometry. It is part of Mr. Yong's flipped classroom. While you view the video at home, okay, and you actually do your homework in class, okay. So this is actually what you are supposed to be learning in school, except now that it's kind of flipped, okay. So you will learn it as home as you watch this video. Okay, let's get right down to it. This is the objective. By the end of this video, I want you to be able to find the distance between 2 points. Okay, and of course there is a formula for that, but I want to show you why the formula works, where does it come from. Okay, so let's jump right into it. Okay, you can here see that I have a Cartesian plane. Okay, you know it as the XY plane with 2 points, okay, A and B. Alright, so what are the coordinates of A? The coordinates of A are 2, 1, and the coordinates of B are 6, 4. Okay, I want to find the distance between them. Alright, how do I do it? Okay, well, you may have realized that everything here, the vertical lines and the horizontal lines, are all at right angles to each other. So where does that lead us? Okay, you'll notice that A and B are the points of an invisible right angled triangle. Okay, I'm going to trace it out with my cursor. I don't know if you can see it, okay, but now I'm going to bring some life into it. Okay, so I repeat, A and B are actually the points, okay, of a right angled triangle, and the distance between them is the hypotenuse. Okay, so it's this length h over here. How do I find it? Okay, recall that the formula, okay, for finding the side of a right angled triangle, the longer side is called Pythagoras theorem. Okay, let's just do a recap. Okay, I have A square plus B square equals to C square. Okay, this is the formula that you learn in Sec 2, and maybe I'll draw a diagram to illustrate it. Okay, so in this right angled triangle, okay, if the smaller sides must be A and B, okay, so the square of these two sides, A square plus B square, will add up to the square of the longer side. Okay, so if I go back to my diagram here, okay, let's actually see how long is the distance of the shorter sides of the triangle. Okay, let's look at the side AC. It's actually 4 units long. How do I know? I just count the squares. 1, 2, 3, 4. Okay, and what is the length CB? Okay, CB is actually 3 units. Can you see it's just 1, 2, 3 units long. Okay, so back to my diagram. Okay, so now, okay, if I have a right angled triangle, okay, and I know the two shorter sides, okay, I know this is 3 units. Okay, oh, pardon me, not 3, it's actually 4 units. Okay, and I know that the vertical height is 3 units. Okay, I'm going to use Pythagoras theorem to find the length of this side. Okay, so let's get down to it. Here's the calculations. 3 square plus 4 square equals to C square. Okay, use your calculator, add this up, sum mental sums. 25 equals to C square, and then you'll find out that, hey, the answer for C, when you take the square root, C is either plus or minus 5. Okay, but obviously lengths can't be negative, so in this case the answer is C equals 5. Okay, so what it means that if I had this situation, okay, it means that I know that the length of H is exactly 5 units. Alright, so that's easy. Alright, so anytime you're given 2 points, okay, like A and B, you can construct invisible right angled triangle and use Pythagoras theorem to find the distance. Sounds easy, doesn't it? Well, it's about to get easier because there's actually a formula for that. Okay, however, I'm just going to pause this video right now. Okay, go on to the second video to continue this session.